All right, 3, 2, representing functions. Let's go! So functions, each element of the domain is paired with exactly one element of the range. Now we've done this before, I believe, but we're going to talk about it in a little different sense and with a little different annotation today. So we have already done this. So if the x value and y values, if they have to only go to one thing. So each y value goes to one place on the other side. So we had these yesterday like this. So if they go to one value, that's okay. If there's multiple y values, so if this one goes to this and this from here, that's not going to be a function. But we'll get to that here. So there's several ways to do that. So key concept. A function in a relation is each domain is paired with exactly one from the range. I think I just said that. Moving on. Vertical line test is used to see if a graph is a function. I still think this is the easiest way to tell. It is like, when in doubt, graph it and do the vertical line test. And most people just take a pencil and just kind of go over the top of it here. So here would be a function. Does it give me that option down here? Nope, they don't give me the option to make a ruler. Sometimes there's a ruler there. So if I go straight up and down here, all the way across, it only goes through that once. That would be a function. This one's not a function because as I go vertically, it will go through here and here. So that would be two y values. That's why that's not a function. This is also a function here because this includes it and this does not, since that's an open circle. So that would still be a function. And you won't see something like this till like pre-calc or calculus. All right, so function notation are equations that are written in a specific form. So here's what you're used to seeing is an equation would be y equals 3x minus 5. That's an equation notation. That's probably not the right terminology, but that's what you're used to seeing. Function notation looks like this, where they give this f of x is really just a way of replacing in your brain y, or you could say the answer. So that would be that's not really all you're looking at there. So this just represents y basically, or the answer, or how it's going to go. And we'll show you that here in a second. So a function value is where they would put, instead of that be f of x, it's going to be f5. And that really just means substitute x for 5. So it's really just shorthand to tell you this. So what that would look like, so you would insert the number 5 for x in the function. So when you see f of x is 3x minus 5, if we saw f of 5, we replace the x here with 5 as well. So those x's are kind of corresponding, I guess you could say. So it's really just saying substitute at 5 for x in this function. That's what that's saying. And the reason this works, because it has to be a function, is because there can't be more than one value for y. That's why this makes a big deal. All right, so identifying whether something is a function. Determine whether this relation is a function and explain why. Well, definition of a function is each domain only goes to one range value. Well, they each go over here straight or to one thing. So therefore, I would say this is a function because mapping that each element, the domain is paired with exactly, and that's the key word there, exactly one member in the range. So determine if this relation is a function. Okay, 7 goes to 12, 4 goes to 9, 2 goes to 3, 5 goes to 0. None of these are going to multiple y's. So I'd say this table is a function because each table of the elements is paired with exactly one element of the range. And I will very much be looking with this exactly word in your homework if you have to write this out. All right, pause this, give it a shot. All right, so each one in the x value is going with exactly one in the y. So I'd say yes, it is. So that cancels these two out. Because it could be represented by a mapping. Well, yeah, of course it can be represented by a mapping, but that doesn't tell me if it's a function or not. So each domain in the range there is only one, which is another way of saying exactly, corresponding element in the range. So A would be my answer. All right, explain, is this a function or not? Go. All right, so again, I'm going to be looking at the x values and the y. So 3 to 2, 1 to -2, 2 to there, 3 to, wait, there's 2 3s. So that means 3 would be going to 2 places. So if I actually graphed this, if I graphed this out, I would be like 3, 2, and 3, -1. So my vertical line test would not work. So no, it is not a range. And that would be because 3 goes to 2 different things. All right, determine whether x equals -2 is a function. So if we graphed this out, it would graph as a vertical line on the x-axis. So really, I would count over 1, 2, here's x. And for every value, no matter what y is, because there's no y here, it would always be that. So does this pass the vertical line test? So the vertical line passes through more than one point on the graph. If I placed a pencil on here, or I'm just going to draw straight up and down. So I would say, no, it does not pass the vertical line test. Therefore, it is not a function. Pause this, give it a shot. Okay, well, they actually did a great job graphing this for you, lucky. So I would just do the vertical line test. So as I move my way across here, it only goes through one thing. There's no double values on the y's. So I'd say, yes, this is a function. All right, function values. Here's where we say this whole, if f of x is this, find f of 4. So what it's going to say is turn this, substitute 4 for x, and then solve what it's going to come out to. So we would replace 4 for both of those x's. From there, we're going to solve just the right-hand side. So you don't have to bring down that side there. So we're going to multiply those out, and then we're going to do the subtraction, and from there we come out with f of 4 equals 8. So same concept here, except with a negative number. So it says we need to have -5 substituted in for x, is what that's saying. So that's what it says, f of this. So we're going to replace -5 for both of those x's. Replace that in there, solve the right-hand side because it's a function. So multiply it out, subtract, comes out to -19. So f of -5 would equal 19. Pause this, give it a shot. All right, so I'm going to substitute 3 in for both x's. So I'm going to say function of 3 equals 2 and 3 plus 5. I'm only going to solve the right-hand side here. So I'm going to go 6 plus 5, and that's going to equal 11. So f of 3 equals 11. That was a funky little thing there. Moving on. Try this one out. All right, so I'm going to say function of -8. I'm going to replace that, replace -8 for both, 2 and -8 plus 5. That's going to go out to 2 times that is going to be -16, positive, negative wins, plus 5. So -16, adding 5 to that would mean going to the right from -16, so that would be -11. That's what we'd get for that. So f of -8 equals -11. Bam. All right, nonlinear functions. So nonlinear would mean it's not a straight line. So the function of ht equals 160t plus 16t squared represents the height of an object ejected downward from an airplane at a rate of 160 feet per second. Find the height of h to the third, or h3. So what this is all we got. I know this seems really complicated. It's really not. All it's saying is substitute 3 in for t in both places. So we replace t with 3 in both spots, or in all 3 technically. So t, t, and t. Replace it in all 3 places, solve the right-hand side. Using PEMDAS here, we will then multiply out, and they kind of skipped a step there, so they squared this first, then multiplied by 16, and then 3 times 160. Add them all together, and it'll come out to h to 3 equals 624. I'm getting tongue-tied for no reason. Keeping going. So now they want to see what would the value of h2z. So same thing up here. So now I'm substituting 2z in for t in all three places. We can still simplify this, but it's not going to give us quite like an answer. So there'll still be z's in there, and that's okay. So we put those in here. So we substitute 2z for all three places. 1, 2, 3. We're going to then multiply out as much as we can. So 16 times 2z would be 64z squared. And yes, you can do that one. And then 320z, and that's probably as far as we can go. Yep. Say, because we can't simplify, those aren't like terms now, so we are done. So we just write h of z2 is that 320z and 64z squared. Moving on. Pause this, give it a shot. All right, so we're going to substitute 2 in for all of these. So h of 2 equals 180 minus 16t, or sorry, 2 squared. So I'm going to square that first to go to 4. 4 times 16 is going to be, oh boy, I don't have my calculator. I think it's 64, 32, 64, 64, yep. 64, 180 minus 64. 116 equals h of 2. I like it when I'm right. All right, so now we need to find h of 3z. Pause this one. I will make you do this one. All right, so h of 3z equals 180 minus 16, and then 3z squared. Okay, so I can multiply this over to here because I can't do anything with that. 3 times 16 times 16 times 3 would be 48. Z squared. And then I can simplify that. Whoops, I was wrong. So you have to do the squared first. So I go square this, which would be 9z squared, because I can't do anything there. And then I'll take that and multiply it by 16. So 16 times 9 is 144z squared, and then 180 minus. There we go. Oh boy, here comes a long one. Standards example. An algebraic form of the function m equals 5d, where d is the number of dollars spent on Mike's car rental donation, or donate to charity, where m is the donation made by Mike's car rental, which is the following represents the same function. Whew. For every $2 donated, Mike's car rental donates 7. That doesn't seem to make sense. Find d is 5m, or graph here, or graph here. Or sorry, table there, graph there. All right, so, hey, I work at a school. Yay, the bell goes off. So the independent variable is d, and the dependent variable is m, after we read the whole thing here. So they gave me d and m here. Say Mike's charity is donated in dollars, d, and so we keep going from there. The independent variable is d, and the dependent variable is m. Dependent's the one that moves. Independent is the one we have control over. So choice A represents a function of m equals 3.5d. That's incorrect because they told us that m equals 5d. So B and C represent the function m equals 1/5 d, which is also incorrect. And then choice D is a graph that looks like m equals 5d, which is correct. So we have to look at the graph, or look at our equation, and then say, does this represent that? Does this represent that? Does this represent that? Does this represent that? Be careful of this one. They switched D and M because that would have been probably my first guess. So moving along. Answer is D. All right, try this one. Same concept. Go. All right, running low on time. So we know we have to look at this equation. where H is the number of hours in the pool is rented, and C is the number that goes to the parent-teacher association, which the following is the same function. Well, this one is H to C, so they can't, those are backwards, so that's not it. For every 2 hours in the pool is rented, the PTA is $10. Well, not for every 2 hours, so it can't be that one. F of H is 2C. Again, that's not the same function there. They put 2C here. So I don't think it's that one. For every 2 hours the pool is rented, the cost for the PTA is $5. So think, oh, whoops, I was wrong again. Man, I'm on a roll. All right, so this will be a great classroom discussion later. I don't think this is right because I'm trying to figure out where did they get 2 from? Why are they saying 2 hours, 2 hours? Yeah, yes, I do work at a school. Why are they having a 2 up here every time? So this will be a great classroom discussion. I feel that the closest one they had to the correct answer would actually be B, because for every 2 hours, they're going to give 10. So if I put a 1 in here, it would come out to 5, would be the $5 would be the cost. Because this is really saying $5 per hour is what it costs. So for every 2 hours, it would be 10. That's the only one that's remotely close. I'm not sure why they have this 2C in here, because for every hour, it's going to be 2 times the number. So if there's 2 hours, it's going to cost them $10. For 3, it's going to be 15. 3 times 2 is not, I'm not sure why that's the case. So I feel that B is the correct answer. If you feel that it's C, maybe I'll give you a prize come class time.